Welcome to homework.
Okay, if you were confused by this question, that could be because where it says 15 degrees, that should be delta S naught. That's supposed to be delta S naught, not 15 degrees. So delta S naught equals 54 joules per Kelvin per mole. How do I know that? Well, joules per Kelvin per mole is the unit of entropy. And I'm guessing, the S got translated as a 5, and I don't know about the delta and the 1. Point is, this is definitely supposed to be delta S and not 15 degrees. Okay, so then really the rest of the information is delta H naught equals negative 75 kilojoules per mole. And we are asked what the value of delta G is at 298 Kelvin. Okay, well, recall that delta G naught equals delta H naught minus the temperature, T, times delta S naught. Well, we've got delta S, we've got delta H. They told us the temperature is 298 Kelvin. So we can go ahead and calculate this, right? Let's do it. Okay, so I see negative 75 kilojoules per mole minus 298 Kelvin times, and what do we have for delta S? We have 54 joules per Kelvin per mole. Let's convert that to kilojoules real quick because we want to have matching units. That would be nice. Right, so 54 joules per mole, 54 in joules, and if we want it to be kilojoules, we say there's 1,000 joules in 1 kilojoule, and we'll get 54 divided by 1,000, or 0.054. Great. So let's put that in here instead. 0.054 kilojoules per mole per Kelvin. And what do we get for delta H? Got to calculate this. Do it off to the side real quick. Negative 75 minus 298 times 0.054, and I get negative 91.092 kilojoules per mole. That's delta G. All right, what are the next questions? Is the reaction exothermic or endothermic? Recall that exothermic and endothermic depend solely on delta H. Is energy released or absorbed? Well, if delta H is negative, we know energy was released and that the reaction is exothermic. That's just purely definitional. There's no greater logic to it than that. Consider delta G now when we talk about exergonic or endergonic. It's the same idea with delta G. It's just now we're talking about the sum of enthalpy and entropy considerations. If it is negative, it's exergonic, and if it's positive, it's endergonic. Well, this is definitely exergonic because delta G naught is less than 0. The same reason that when we looked at delta H and saw it was less than 0, we said it was exothermic. This is exergonic. Energy will be released when this reaction happens at 298 Kelvin.